Hello everyone, I'm Shai Almog. When we think monolith, we think old and crusty, and when we think about microservices, we think small and simple. Both conceptions are wrong, and I will dig into that in my talk. I'll just briefly introduce myself. I've worked as a consultant for over a decade, founded a few companies, wrote a few books, and worked everywhere from Sun Microsystems and Oracle to startups like Lightroom. My current book is Practical Debugging at Scale. I have another coming out that covers Java from 8 to 21. When we think about monolith and microservices, both architectures are pretty darn different. Yet when I talk to teams and even when I read the definition, the lines are much blurrier than most would assume. I recently led a conference panel that covered the subject of microservices versus monoliths. The consensus is in the panel is even with the pro monolith person was that monoliths don't scale as well as microservices. This is probably true for the monstrous monoliths of old that Amazon, eBay, etc. replaced. Those were indeed huge code bases in which every modification was painful and their scaling was challenging. But that isn't a fair comparison. New approaches usually beat the old approaches, but what if we build a monolith with newer tooling? Would we get better scalability? What would the limitations and what does a modern monolith even look like? To get a sense of the latter part, you can check out the Spring Monolith project. It's a modular monolith that lets us build a monolith using dynamic isolated pieces. With this approach, we can separate testing, development, documentation, and dependencies. This helps with isolated aspect of microservices development with little of the overhead involved. It removes the overhead of remote calls and the replication of functionality such as storage, authentication, etc. We can use most of the microservice scaling tools to scale our monoliths. A great deal of the research related to scaling and clustering was developed with monoliths in mind. It's a simpler process since then there's only one moving part, the application. We replicate additional instances and observe them. There's no individual service that's failing, and we have fine-grained performance tools, and everything works as a single unified release. I would argue that scaling is simpler than the equivalent microservices. We can use profiling tools and get responsible approximation of bottlenecks. Our team can easily and affordably set up staging environments to run tests. We have a single view of the entire system and its dependencies. We can test an individual module in isolation and verify performance assumptions. Tracing and observability tools are wonderful, but they also affect production and sometimes produce noise. When we try to follow through on a scaling bottleneck or performance issue, they can send us down the wrong rabbit hole. There's also no requirement for a single database within a monolith. It isn't out of the ordinary to have an SQL database while using Redis for cache. But we can also use a separate database for time series or spatial data. We can use a separate database for performance as well, although in my experience, this never happened. The advantage of keeping our data in the same database is tremendous. The fact that we can complete a transaction without relying on eventual consistency is an amazing benefit. When we try to debug and replicate a distributed system, we might have an interim state that's very hard to replicate locally or even understand fully from reviewing observability data. A common misconception is that microservices are simply broken down monoliths. This isn't the case. I've talked to quite a few people who still hold that notion. To be fair, they might have a point. This is how AWS defined microservices. This is a bit of a mouthful, so let's go over this one part at a time. The definition starts with the words architectural and organizational approach to software development. The most important thing about microservices is how they are organized. The fact that we can break down the system and work with smaller projects helps us organize our team better. This is the primary benefit of microservices. The rest of the sentence talks about composing software from small independent services that communicate well over well-defined APIs. There are several interesting points in this sentence. First, the word composed does a lot of heavy lifting here. In a monolith, we don't really compose software, we write it. With microservices, a lot of the heavy lifting is composition. We connect separate services and wire them to one another. The well-defined API part hints to another big concept. With microservices, we have as many products as there are microservices. Every one of these services is a standalone product with its own API. Small self-contained teams go back to the point we made initially when discussing the fact that this is an organizational pattern, but they include two important details. Small teams are a crucial concept in large enterprise deployments. Self-contained is another major detail. A monolith split into smaller elements isn't self-contained. We will get back to this point. This point I don't like. It makes promises without defining constraints, easier to scale, faster to develop, faster time to market. Such claims need to be qualified, and this definition doesn't qualify them. It isn't necessarily wrong, but we need a way to understand when these benefits can come into play and what are the trade-offs we make. Smaller monoliths might fit the definition, but they don't if you read between the lines. The words independent, easier to scale hint at the problem. The problem and advantage of monolith is a single point of failure. By having one service, we can usually find problems more easily. The architecture is much simpler. If we break a service down into smaller pieces, we essentially create distributed points of failure. If one piece along the chain fails, the entire architecture breaks down. That isn't independent and it isn't easier to scale. Microservices are not small monoliths, and breaking down the monolith isn't only about working with smaller projects, it's about shifting the way we work. When we say divided by business function, we're referring to logical division. A microservice is a standard product that provides a complete package. This means that the team responsible for the microservice can make all the changes required for the business without dependencies. So good examples for microservices would be billing, invoicing, user tracking, etc. Bad examples would be database service, web, or business logic as one block. In red, we can see the more traditional layered architecture, which is very different conceptually from microservices. Automation through CI/CD is crucial for microservices. Without continuous delivery, the code of updating would eliminate every benefit of microservices. Independent deployment implied, since commit on one microservice will only trigger the CD of that specific service. We can accomplish this through Kubernetes and infrastructure as code solutions. A microservice should hide the underlying implementation details. A service acts as a stationary product that publishes an API for other products. We commonly accomplish this via REST interfaces, but also messaging middleware. This is further enhanced with API gateways. Decentralized with no single point of failure, otherwise we would distribute failure. Failures should be isolated. Without this, a single service going down could create a domino effect. Circuit breakers are probably the most important tools for isolating failures. To satisfy this dependency, every microservice handles its own data. This means many databases, which can be challenging at times. Observability is required to deal with failure on scale. Without proper observability, we're effectively blind as the various teams can deploy automatically. This is all good and well, but what does that mean in practical terms? If your company doesn't have good DevOps and platform engineering teams, microservices aren't an option. Instead of deploying one application, we might deploy hundreds because of a migration. While individual deployments are simple and automated, you will still throw a lot of work at operations when something doesn't work or doesn't connect. when new services need to be integrated or the service configuration should be adapted, operations carry a greater burden when working with microservices. This requires great communication and collaboration. It also means the team managing specific service needs to take some of the ops burden back. That isn't a simple task. Stateless services would be ideal. Carrying a state makes everything far more complex. If we stored the state in the client, we need to send it back and forth all the time. If it is on the server, we would need to either fetch it constantly, cache it, or save it locally. And then all the interaction would be performed against the current system. That eliminates the scalability of the system. The Saga pattern works by using compensating transactions to undo the effects of a Saga. If it fails, when a Saga fails, the compensating transaction is executed to undo the changes made by the previous transaction. This allows the system to recover from failures and maintain a consistent state. We can accomplish this with tools such as Apache Camel, but this is non-trivial and requires far more involvement than typical transactions. In a modern system, the equivalent undo operation that will restore the state back. That is non-trivial. There are several tools for Saga orchestration, but this is a big subject that is beyond the scope of this video. I'll just explain this in broad terms. Let's say we have a money transfer process. For this to work, we need to first allocate funds, then verify that the recipient is valid and exists. Then we need to deduct the funds from our account. And finally, we need to add the money to the recipient account. That is a successful transaction. With a regular database, this will be one transaction. If a failure occurs when allocating funds, we need to remove the allocation. So we need to create a separate block of code that does the inverse operation of the allocation. If verifying a recipient fails, we need to remove that recipient, but then we need to also remove the allocation. If deducting the funds fails, we need to restore the funds, remove the recipient, and remove the allocation. Finally, if adding the funds to the recipient fails, we need to run all the undo operations. What's important to understand about Saga is that it avoids the classic ACID database principles and focuses on eventual consistency. That means operations would bring the database to a consistent state at some point. That is a very difficult process. Imagine debugging a problem that only occurs when the system is in an inconsistent state. Another problem in Saga is illustrated in the CAP theorem. CAP stands for consistency, availability, and partition tolerance. The problem is we need to pick any two. Don't get me wrong, you might have all three, but in the case of a failure, you can only guarantee two. Availability means that requests receive responses, but there's no guarantee that they contain the most recent writes. Consistency means that every read receives the most recent writes on an error. Tolerance means that everything will keep working even if many messages get dropped along the way. This differs greatly from our historic approach to failure with transactions. Hopefully, you now understand how hard it is to deploy microservices properly. We need to make some big compromises. This new way isn't necessarily better. In some regards, it's worse. But the proponents of microservices still have a point. We can gain a lot by microservices and should focus on those benefits too. We mentioned the first requirement up front, DevOps. Having a good DevOps team is a prerequisite to considering microservices. I saw teams trying to hack their way through this without an ops team, and they ended up spending more time on operational complexity than writing code. It wasn't worth the effort. The biggest benefit of microservices is to the team. Splitting teams to vertical teams that work independently is a tremendous benefit. The most modular monolith in the world can't compete with that. Splitting a monolith is hard, but doable. Unifying microservices to a monolith is probably harder. I'm unaware of anyone who seriously tried to do that, but would be curious to hear stories. In order to move a microservice architecture, we need a bit of a mind shift. A good example is in the database. A good example would be user tracking. Microservice, in a monolith, we would write the data to a table and move on with our work. But this is problematic. As data scales, this user tracking table can end up containing a great deal of data that is hard to analyze in real time without impacting the rest of the operating system. With a microservice, we can offer several advantages. The interface to the microservice can use messaging. That means that the cost to send tracking information will be minimal. Tracking data can use a time series database, which would be more efficient for this use case. We can stream the data and process it asynchronously to derive additional value from that data. There are complexities. Data will no longer be localized. So we send tracking data asynchronously. We need to send everything necessary, as the tracking service won't be able to go back to the original service to get additional metadata. But it has a locality advantage. If regulation changes about tracking storage, there is a single place where this is stored. Did you ever push a button to a release that broke production? I did, more than once, way too many times. But that's a terrible feeling. Microservices can still fail in production and can still fail catastrophically, but usually their failure is more localized. It is also easier to roll them out to a specific subset of the system, a canary, and verify. These are all policies that can be controlled in depth by the people who actually have their fingers on the user's pulse, the ops. Observability for microservices is essential, expensive, but also very powerful, since everything occurs at the network layer. It is all exposed to the observability tools. An SRE or a DevOps can understand failure with greater details. This comes at the expense of the developer, who might need to face increased complexity and limited tooling. Applications can become too big to fail. Even with modularity, some of the largest monoliths around have so much code it takes hours to run through a full CI/CD cycle. Then, if the deployment fails, reverting to the last good version might also take a while. It is hard to put a finger at the size that makes a monolith impractical. But here's what you should ask yourself. How many teams do we have or want? As a project grows, your pull requests will spend more time waiting to merge, and issues will take longer to resolve. This is inevitable, as complexity tends to grow in the project. Notice that the new project will have larger features that might sway the results once you account for that in the project stats. The decrease in productivity should be measurable. At some point, a huge project becomes so big that the experts start losing track of the details. This becomes a problem when bugs become untenable, and there's no authoritative figure that can make a decision without consultation. Microservices will cost more. There's no way around it. There are special cases where we can tune scale, but ultimately observability and management costs would remove any potential cost savings. The trade-off of monolith versus microservices are illustrated nicely in the following radar chart. Notice that this chart was designed with large projects in mind. The smaller the project, the better the picture is for monolith. Notice that microservices deliver benefits in larger projects, fault tolerance and team independence, but they pay a price and cost. They can reduce R&D spend, but they mostly shift it to the DevOps, so that isn't a major benefit. The complexity of microservices is immense and sometimes ignored by the implementing team. Developers use microservices as a cudgel to throw away parts of the system they don't want to maintain, instead of building a sustainable, scalable architecture worthy of replacing a monolith. I firmly believe that projects should start off with a monolith. Microservices are an optimization for scaling a team, and optimizing prematurely is the root of all evil. The question is, when is the right time to do such an optimization? There are some metrics we can use to make that decision easier. Ultimately, the change isn't just splitting a monolith. It means rethinking transactions and core concepts. By starting with a monolith, we have a blueprint we can use to align our new implementation as it strengthens. Thanks for watching. Please check out my book and follow me for more videos like this. Thank you.